So we were discussing action and effect pair, and in that we discussed that force is, if force is action, then it has two effects. One is rigid body translation, where all the points on the body, they move by same amount, and therefore there is no change in relative distance between any two randomly chosen points on a body during the motion. तो उसको हम बोलते हैं रिजिड बॉडी ट्रांसलेशन. एंड देन वी हैव रिलेटिव ट्रांसलेशन. सो फोर्स के दो इफेक्ट होंगे, एक होगा रिजिड बॉडी ट्रांसलेशन और दूसरा होगा relative translation. Similarly, we saw that movement had two possible: rigid body rotation, and second one is relative rotation. So now we are going to consider two types of forces. One is axial force and another one is shear force. And we are going to consider two types of movements. One is bending movement and another is twisting movement. You must have heard all these words during strength of materials. So these are the four basic actions that a member can be subjected to. So first of all, we will try to define these actions. Are you with me, Akshay?
Yes, sir.
Okay. Now, I'm going to ask you a question. What are the different categories of the structural elements? Yes, Akshay, go ahead. How do we classify various structural elements that we see in a building? For example, beam, then column, then you have slab. So what is the categorization? Are you aware of that?
Like there are different sections like cantilever beam, then supported beam.
Yeah, but what is the difference between slab and beam? What is the basic difference? Yes, Akshay.
So the slab is supported on the beam.
Okay, apart from that, is there any geometrical difference? Shape wise, is there any difference?
Beam is in a rectangular.
Not
Say,
necessary. Not necessary. Beam can be.
not necessary, but in general, if we see a look at a residential building, it's in rectangle slab. It's totally horizontal, like it's a plane surface on the top of the beam.
Okay, so geometrically, we classify all the structural elements around us in three categories. First category, where one dimension of the structure is larger than other two dimensions. So the one I have drawn here. So beam, columns, they fall in this category. Truss members, they fall in this category, where their one dimension is dominant over the other two orthogonal directions. ऐसे members को हम बोलते हैं 1D और skeletal members. Are you with me?
Yes, sir.
So one dimensional or skeletal members. Why skeletal? You look at your own skeletal, most of the bones do exhibit this property that they have one dimension dominant over the other two. So we call them as 1D or skeletal members. Then we have slab like elements which have their two dimensions dominant over the third one. हम उनको बोलते हैं 2D or planar elements. And then we have certain elements like earthen dam where all the three dimensions are dominant. तो उनको हम बोलेंगे 3D members or space members. So 1D, 2D and 3D. This is the categorization of structural elements that we see around us. Now, when we are trying to define axial force, we understand intuitively that it is force along the axis. Do you agree with me, Akshay?
Yes, sir.
So if axial force is force along the axis, we will have to first define what do we mean by axis. So do you have any clue what is axis of a skeletal member or axis of 1D member? Okay, let me ask you a series of questions. Let me consider one point on this member. Through this point, how many axes can pass? Yes, Akshay.
Which axis?
Through, if I consider one point on an object, 1D or skeletal object, how many axes can pass through this point? Yes, Akshay, go ahead.
3.
Why 3? You are talking about this XYZ axis passing through this point. But in general, this is also axis. This is also axis. This is also
axis.
Yes. So if you consider a point on a 1D or skeletal member, through that point, infinite axis can pass. So when I say axial force, this is the force along which of these axes. So first of all, I will have to distinguish between, or I will have to define what do I mean by axis of a skeletal member. Do you agree with me, Akshay? Yes, Akshay. Is there any issue? Am I not audible? Okay. Roll number 43, Shivraj. Can you unmute yourself?
Yes, sir.
Yes. Please keep yourself unmuted. Are you with me till this point?
Yes, sir.
Okay. So we are trying to now define out of this infinite access that can pass through a randomly chosen point on 1D or skeletal members, which one is I am going to call it as axis by definition. तो वो define पहले करते हैं. So वो define करने के लिए first of all I am going to define something called as cross section. Are you with me? Shivraj?
Yes, sir.
Yes. So what is cross section? Section taken across the length of 1D or skeletal member. So what is the definition of 1D or skeletal member? It is the member having its one dimension dominant over the other two orthogonal dimensions. So that one dominant dimension, I am going to call it as length. And if you take section across this length, so I am now switching on my video. Let me know if I am visible. Am I visible, Shivraj?
Yes, sir. Yes, sir.
So let us consider this is a 1D or skeletal member, and the greatest dimension is length. So this is the length. Section taken across the greatest dimension of 1D or skeletal member. This section, that is cross section. Are you able to understand this?
Yes, sir.
So what is the cross section of this member? It is circular. Happy?
Yes.
Yes, sir.
Now look at this member. So if I take section across the length, its cross section is semicircular. Are you able to understand this?
Yes, sir.
Yes, sir.
So we have unambiguously defined something called as cross section of a 1D or skeletal member. Now look at this cross section of this 1D member and tell me, can you locate its centroid? Are we equipped with everything that is required to locate centroids of cross sections? Yes. Are you with me?
Yes, sir.
So where is the centroid? So if this is a circular cross section, the center point of that is the location of centroid. Do you agree with me?
Yes, sir.
Okay. So therefore, look at the point that I am trying to make. We are going to define something called as cross section, section taken across the length of skeletal member, and we can locate centroid of that cross section, however, how much ever irregular shape that cross section is having. We are equipped with everything that is required to locate centroid of a section or centroid of a lamina that you have learned in applied mechanics. Are you with me?
Yes, sir.
Okay, so now I will stop the video. Let us go back to the screen. Now tell me, how many cross sections can a 1D or skeletal member have? कितने cross sections हम ले सकते हैं? Yes, go ahead, Shivraj. How many cross sections can you take? Infinite, because I can take section anywhere between. Let us say this is the origin, so x equal to 0 to x equal to L. In x equal to 0 to L, I can take infinite number of sections across the length, and therefore ideally a 1D or skeletal member will have infinite cross sections. Do you agree with me?
Yes, sir.
Okay. Now for each and every cross section, I can locate centroid, and these centroids will lie one behind the other as long as the shape of cross section and size of cross section remains unaltered. Do you agree with me?
Yes, sir.
हाँ, तो ये सारे centroids एक के पीछे एक रहेंगे. Now if you join that line which joins the centroids of all the cross sections, by definition I am going to call it as axis of a skeletal member. Are you with me?
Yes, sir.
So how do we define axis of a skeletal member? It is longitudinal because it is along the length, centroidal because it passes through the centroids of all the cross sections, So by definition, when I say axis of a 1D or skeletal member, it is longitudinal and centroidal axis. Are you with me?
Yes, sir.
So longitudinal and centroidal axis. Now I am going to ask you a question. What kinds of axial forces that you have learned so far? Have you learned that there can be axial compression and there can be axial tension?
Yes, sir.
Huh. So can you tell me how does the axial compression look like? How will you define axial compression? So if this is a 1D or skeletal member, ये अगर 1D और 1D skeletal member है,
If the two forces are acting towards each other,
so it is like this, right?
so two axes.
हाँ. So अब जरा देखो यहाँ पे when we call axial compression and how do you define axial? How do you show axial tension? जरा बताओ.
Away from each other, sir.
Yes. So axial tension will be seen something like this. This is the axis that I have drawn, and may it be axial compression or may it be axial tension. The forces are along the axis of the member. Do you agree with me?
Yes, sir.
So therefore, we call them as axial forces. Now my question is axial tension or axial compression a single force or is it a pair of forces?
Pair
Yes.
of forces.
And it is not any randomly picked up pair of forces. No, it must have same magnitude. Do you agree with me?
Yes, sir.
And not only that, it must be their directions must be opposite to each other. So if one of the force is towards up, the another force has to be towards down. Do you agree with me?
Yes, sir.
Similarly, if you look at this axial tension, these two forces, they must have equal magnitude. They must have same line of action. That line of action must match with the axis of the member, and their sense must be opposite. Means one, if one is towards, not sense, their direction. If one is upwards, the another one is downwards. Are you with me?
Yes, sir.
Okay. So first thing that we understand that whenever I say axial compression or axial tension, it is pair of forces. Agreed?
Yes, sir.
It is not a single force. And ये pair of forces में दोनों forces equal magnitude के है और opposite direction के. Do you agree with me?
Yes, sir.
So how do you define axial compression or axial tension? It is pair of forces having their line of action along the axis of a skeletal member. If that pair tries to contract the member, I am going to call it as compression. If that pair tries to elongate the member, I am going to call that pair as axial tension. Do you agree with me?
Yes, sir.
And what is the sign convention? So let us also have sign convention here. Tensile forces, I am going to call it as positive. A pair. अब जरा देखो इस साइन कन्वेंशन में साइन कन्वेंशन बहुत मजेदार है. If I consider this as x-axis, by definition, one of the forces with positive side and another forces with negative side. Do you agree with me? Shivraj?
Yes, sir.
So if I consider this as a x-axis, one of this force is positive and another force is negative. But this is as far as application of equations of equilibrium is concerned. But when I define the sign convention for pair of forces, there is another sign convention parallelly going on. And what is that sign convention? If this pair of equal and opposite forces is trying to elongate the member, then I am going to call that pair as positive. दोनों को मिला के पॉजिटिव बोलेंगे. Are you with me?
Yes.
Okay. So this is another sign convention which is simultaneously going on when we interpret the results of member being stretched or compressed. तो एक साइन कन्वेंशन तो अपने इक्वेशंस ऑफ इक्विलिब्रियम के लिए है. Along positive x, the force is positive. Along negative x, the force is negative. However, when it comes to the sign convention for axial force, which is pair, a pair that elongates the member will be treated as positive. Where and the pair that contracts the member will be treated as negative. Are you with me?
Yes, sir.
Okay, so we are clear on this. Now, can you quickly tell me what is the effect of this axial force? Let us say it is compressive in nature, and let us say it is tensile in nature. So, what is the effect?
Change in length.
Yes, change in length. But if it is compressive, there is shortening of the length. Do you agree with me?
Yes, sir.
And if it is tensile in nature, then there is elongation of length. However, instead of saying it as change in length, we will say that it is relative deformation along the axis. Do you agree with me? For
Yes,
example,
sir.
if I consider this point and this point, then after application of this P, this point may come here and this point would have come here. So there is distance between these 2 points has been relatively changed. Do you agree with me?
Yes, sir.
So therefore हम इस effect को क्या बोलेंगे? Though we know it is change in length, but to put the things in context, we are going to say it is change in relative distance between the randomly chosen particles. So I am going to say it as relative translation. Are you with me?
Yes, sir.
So देखो फोर्स का इफेक्ट हमेशा कौन सा रहता है? रिलेटिव. फोर्स का इफेक्ट हमेशा क्या रहता है? ट्रांसलेशन. सो इट इज गोइंग टू बी रिलेटिव ट्रांसलेशन. बट जो कि ये एक्सियल फोर्स है, सो देयरफॉर दिस रिलेटिव ट्रांसलेशन इज अलोंग द एक्सिस. आर यू विथ मी?
Yes, sir.
If the pair of forces that you have chosen is compressive in nature, this relative translation will be contractive but along the axis. If the pair of forces that you have chosen is tensile in nature, this relative translation will be elongation. Do you agree with me?
Yes, sir.
Okay. So you have to understand, whenever I say axial force, it will never produce any rigid body translation. It will always produce relative translation, and that too along the axis. Happy?
Yes,
Are
sir.
you with me? Okay. So this is the effect of axial force. Now let us try to define what do we mean by shear force. तो अब जरा एक typical example लेते हैं. Let us consider this beam is being loaded with force P at the midspan. So this is L by 2, this is L by 2. And these are the two reactions. We know that by symmetry, these two reactions are P by 2 and P by 2. Are you with me?
Yes, sir.
Okay. And now I am going to consider cross section to this 1D or skeletal member at distance x, such that x is less than L by 2. X is less than L by 2. Now, if I take this section from exactly from where am I taking this section? So to demonstrate that, what I will do is, instead of drawing this beam as a single line, I am going to draw it with double line notation. So this is the depth of the beam. Are you able to imagine this? This is width of the beam. Are you with me? Shivraj?
Yes, sir.
Okay. Now, let us go ahead. So when I take a section like this here, so that section can be seen in this view, something like this. This is the section. Happy? Are you with me?
Yes, sir.
So from this, the distance of this section is x and total length is L. This x is less than L by 2. Now, my question, from where does this section pass? तो अब हम एक काम करेंगे. I am going to consider I can consider this beam to be made up of n number of cross sections. Do you agree with me? Theoretically, infinite cross sections prevail, but if you look at it macroscopically, there are going to be n number of cross sections. Two consecutive cross sections are going to have a gap between them. Agreed?
Yes, sir.
Okay. So what I'm trying to do is, at this, in the neighborhood of X, there must have been one cross section like this, and this is just left of X, and on just right of X, there must have been another cross section like this. Are you with me? Shivraj, are you with me?
Yes, sir. Yes, sir.
Okay. So what I'm trying to do is, I'm trying to pass a section at X which falls between the vacuum between these two consecutive cross sections shown by black and blue line. Happy?
Yes, sir.
Are you able to imagine this? So that's what I'm going to draw now. So this is the section that I have taken. On left hand side of it, you have a cross section which will be seen as a line in the front view. On the right hand side of it, you have another cross section which will also be seen as a line of same length in this view. Are you able to imagine this, Shivraj?
Yes, sir.
Okay. Now question. What is the algebraic sum of all the forces on left hand side of this section? ये जो section X पे लिया है उसके left hand side में algebraic sum क्या है बोलो? The only force prevailing there is P by 2 and it is acting in upward direction. Agreed?
Yes, sir.
So if I sum up all the forces on left hand side of this cross section, the total sum turns out to be P by 2 upwards. Happy? Are you
Yes,
with
sir.
me? Okay. Now let us do that exercise for all the forces lying on right hand side of the section. So on right hand side of this section, how many forces are there? You have downward P and upward P by 2. So what is the net sum? Net sum is P by 2 downward. Do you agree with me?
Yes, sir.
Okay. Now just look at these two cross sections which are placed consecutive to each other. They will try to slide over one another under the action of this pair of forces, P by 2 up and P by 2 down. Do you agree with me?
Yes, sir.
So just let me switch on my video once again. Are you able to see the video? Are you able to see me?
Yes, sir.
So these are the two consecutive cross sections. They will try to slide over one another due to action of P by 2 and P by 2, equal and opposite forces, but in opposite nature. Are you with me?
Yes, sir.
Okay, so let me switch off the video and let us come back to this screen. So this pair of forces together is called as shear force at a cross section. Are you with me?
Yes, sir.
So in which direction the shear force acts? It acts along the cross section and perpendicular to the axis. Agreed?
Yes, sir.
हाँ, तो कौन से डायरेक्शन में एक्ट हो रहा है? एक्सिस कौन से डायरेक्शन में है? देखो, this is the direction of axis, and these two forces which are equal in magnitude but opposite in nature, and they are perpendicular to this axis. Do you agree with me?
Yes, sir.
So there, and what is their effect? So this cross section, let us say under this P by 2, it moves here. And this cross section under this effect of P by 2, let us say it moves here. So what has happened? These two cross sections have slided over one another. Are you with me?
Yes, sir.
So if I take two molecules just before the sliding, then there is a change in distance between these two molecules relatively. Do you agree with me?
Yes, sir.
And this relative change has occurred in which direction? It has occurred perpendicular to the axis in the direction of this shear force. Do you agree with me?
Yes, sir.
So what is the effect of shear force now? So we have defined what is shear force. Let us also define its sign convention. So a pair of shear force which is seen in this fashion, we treat it as positive. So upward on the left hand side of section and downward on the right hand side of section will be treated as positive. Happy?
Yes.
Okay. You have to understand this shear force is also not a isolated force. It is pair, and we have assigned a sign convention. Sign convention is of this nature. And what is the effect? So let me write down its effect. It is relative translation, not rigid body translation. Are you with me? Perpendicular to the axis. And in the direction of shear force. And in the direction of shear force. So देखो दोनों forces थे, एक था axial force, दूसरा था shear force. Both these forces are pair of forces. They are not isolated forces, and they cause relative translations. Axial force causes relative translation along the axis. Shear force, being perpendicular to the axis, causes relative translation normal to the axis. Are you with me?
Yes, sir.
Okay. I'm very sure that all of this you must have learnt in strength of material, but I'm going to spend some time on revision because this is absolutely required when we design a member. Happy?
Yes, sir.
Okay. Now, let us try to define something called as bending moment and twisting moment. Are you aware of what is the difference between bending moment and twisting moment? पता है आपको? Chalo. So for that I will have to I will require to on the video. Just let me know, are you able to see me?
Yes, sir.
Okay. अब जरा यहाँ पे जान लो. I'm going to apply two types of moments and you are going to tell me which one is bending and which one is twisting. So imagine this is the member and I have applied a moment like this. So again you have to understand these are two moments that I am applying. One is of this nature, another is of opposite nature. Are you able to see that?
Yes, sir.
So again, it is a pair of moments. It is not a moment in isolation. That you have to understand. One moment is applied in this form, another moment is applied in this form. Happy?
Yes, sir.
So is it torsion or is it bending? Tell me.
Torsion, sir.
It is torsion, right? Now, I am applying this moment here, देखो ऐसे वाला, and this moment here. Again, I am applying two moments which are equal and opposite. Are you with me?
Yes.
अब ये मोमेंट क्या है? Is it bending or torsion?
Bending moment.
Bending moment. अब जरा देखो, I am going to apply now two moments again, एक ऐसे and another ऐसे. So two equal and opposite moments have been applied. Is it bending or torsion? Tell me.
Bending.
Still bending. So now can you define what is bending and what is twisting? How do we define what is bending and twisting? So देखो, if a pair of moments is applied about an axis which happens to be the length of a 1D or skeletal member. मतलब 1D और skeletal member के axis के about अगर मैं moment apply करता हूँ, देखो axis के about, moment is applied about the axis, then we call that moment as twisting moment. Do you agree with me?
Yes, sir.
देखो फिर से एक बार दिखाता हूँ. I am applying both the moments. No doubt it is pair of moments, but both these moments they have been applied about the axis of a skeletal member, isn't it?
Yes, sir.
तो ऐसे मोमेंट को हम बोलेंगे ट्विस्टिंग. एक्सिस के अबाउट पेयर ऑफ मोमेंट्स है, उन पेयर ऑफ मोमेंट्स को मिला के हम बोलते हैं ट्विस्टिंग मोमेंट. नाउ व्हाट इज बेंडिंग मोमेंट देन? बेंडिंग मोमेंट इज द मोमेंट applied about an axis which is normal to the axis of skeletal member. For example, I am applying moment like this. तो ये जो मोमेंट है, इस मोमेंट का डायरेक्शन कौन सा है या फिर इस मोमेंट का एक्सिस कौन सा है? इट इज अप्लाइड अबाउट दिस एक्सिस. डू यू एग्री विद मी? शिवराज,
Yes, sir.
this moment which I am applying is applied about this axis, and this axis is perpendicular to the axis of skeletal member, isn't it?
Yes.
Okay, तो अब जरा ये वाले movements देखते हैं. What is the axis of this moment? It is this axis. Do you agree with me? I am applying moment along this axis, vertical one. Happy?
Yes.
Are you able to visualize? I am applying moment like this. So the axis of moment is this vertical axis, and this axis again happens perpendicular to the axis of a skeletal. So whenever you have moments applied about an axis which is perpendicular to the axis of skeletal member, it causes bending. Do you agree with me?
Yes, sir.
Okay, so let us stop here and let us go back to this one. So imagine now you have a beam like this. Again, same example. This is P. This is P by 2. This is P by 2. Because I am applying this P at the mid span. So this is L by 2, L by 2. So by symmetry, both the reactions are going to be P by 2, P by 2. And again, I am going to repeat the exercise at distance X. At distance X, I am going to take a section. On left hand side of this section, there will be a cross section. On right hand side of this section, there will be consecutive cross section. So between these two consecutive cross sections, there is a vacuum. In that vacuum, I have taken section X. Are you with me?
Yes, sir.
Okay. Now let me take moment of this, all the forces on left hand side at this distance X. तो कैसे दिखेगा देखो. This is, let me draw it here. So this is the section at distance X. This is the section on just left hand side of the section taken. This is the cross section on just right hand side of the section taken. Are you with me?
Yes, sir.
And what is the distance between these two cross sections before bending was or before any load was applied? This distance, let me call it as delta. Happy?
Yes, sir.
Okay. Now on left hand side, what is moment of all the forces? Tell me. It is P by 2 into X. On left hand side, you have only one force. It is P by 2 into X. Do you agree with me?
Yes, sir.
And in which direction it is? So I have to hold the object at this point. So this P by 2 is going to cause clockwise rotation. It will have tendency of causing clockwise rotation. So this moment is going to be clockwise in nature. Do you agree with me?
Yes, sir.
And how much is that moment? That moment is P by 2 into X. Happy?
Yes, sir.
चलो अब जरा ये राइट हैंड साइड के फोर्सेस देखते हैं. राइट हैंड साइड में कौन कौन से फोर्सेस है? देयर आर टू फोर्सेस. वन इज P एंड अनदर इज P by 2. व्हाट इज द मोमेंट ऑफ दिस P by 2? कैन यू टेल मी at X, at this section? It is P by 2 into L minus X. Do you agree with me?
Yes, sir.
This distance is L minus X. So this moment is P by 2 into L minus X. And what is the nature of this moment? It is anti-clockwise in nature. Happy?
Yes, sir.
P by 2 into L minus X. That's what I am going to write. Okay. And what is the moment of this P here? Is P ka moment kya hai? So I know that this distance is L by 2. So how much is this distance? It is L by 2 minus X. So it is clockwise in nature, and that is P into L by 2. Do you agree with L by 2 minus X? Do you agree with me?
Yes, sir.
Yes, sir.
Okay. And now I will call this anti-clockwise moment as positive. So what is the net moment? इन दोनों का अगर मैं सम कर लेता हूँ तो क्या आता है? देखो PL by 2 minus PX by 2. And this moment being clockwise, I am going to call it as negative. So minus PL by 2 minus PX by 2. Happy?
Sir.
Are you with me? Yes, go ahead. Shivraj?
Yes, sir.
Okay. So now look at this. This is minus Px by 2. And this minus minus becomes plus Px by 2. So therefore, what what we are going to get is
Px.
just give me a second. Did we make any mistake? No. Just a second. P by 2 into L minus x.
Px only.
Sir,
Ah,
it
by
px
2
only, यहाँ पे not by 2 in the bracket.
Yes,
yes,
sir.
you're right. So this is going to be only minus px by minus px. So minus of minus px becomes plus px. So px minus px by 2 is only px by 2. Do you agree with me?
Yes, sir.
And this pl by 2 and this pl by 2, they are going to get cancelled. So therefore, what is the net sum of these moments? Net sum of these moments, that net sum I have worked out, and that net sum of moment has turned out to be positive. I had treated anti-clockwise as positive, so this sum has worked out to be anti-clockwise, and that is px by 2. Do you agree with me?
Yes, sir.
चलो,
Yes, sir.
इस मोमेंट का एक्सिस कौन सा है बताओ? This axis, that axis is perpendicular to the plane of board. Agreed?
Yes, sir.
And perpendicular to the plane of board, that means it is perpendicular to the axis of skeletal member. Axis of skeletal member is this longitudinal axis. Do you agree with me?
Yes, sir.
हाँ, तो हम ये जो पेयर ऑफ मोमेंट्स हमें मिली है, जो कि मैग्नीट्यूड में तो सेम है लेकिन नेचर में अपोजिट है, तो इस पेयर ऑफ मोमेंट्स को मिला के हम कौन सा मोमेंट बोलेंगे? क्या हम इसको बेंडिंग मोमेंट बोलेंगे या ट्विस्टिंग मोमेंट? तो हम इसको बोलेंगे बेंडिंग मोमेंट. व्हाई? बिकॉज द एक्सिस ऑफ मोमेंट्स इन दिस पेयर इज परपेंडिकुलर टू द एक्सिस ऑफ ए स्केलेटल मेंबर, तो इसलिए हम इसको बोलते हैं बेंडिंग मोमेंट. आर यू विथ मी? By definition. Happy? Shivraj? Shivraj, am I audible? Am I audible?
Yes, sir, you are audible.
Yes, yes, sir.
Okay. So, are you with me till this point?
Yes, sir.
Okay. See, I rely on, when it is an online class, I totally rely on the responses from students. So unless I get the response, I won't proceed. So in this class, it is going to be like this. So please respond. So p by 2 into x and px by 2. This is pair of equal and opposite moments. One is clockwise, another is anti-clockwise. But this pair together, we call it as bending moment at a section. And what is our sign convention for bending moment? So sign convention is, if on left hand side it is clockwise and on right hand side it is anti-clockwise, this pair together we treat it as positive and we call it as sagging bending. Are you with me?
Yes, sir.
Yes. Okay. Now let us try to look at what is the effect of this bending moment. This bending moment का effect क्या है वो देखने की कोशिश करते हैं. So the cross section which is marked in blue on left hand side and the cross section which is marked in black on right hand side, under the action of these two equal and opposite moments, both these cross sections will rotate. The blue one will rotate clockwise, the black one will rotate anti-clockwise. Do you agree with me? Do you agree with me?
Yes, sir.
Yes.
Yes, sir.
Yes. So what is the consequence? Consequence is the original distance between the two molecules was delta here. So for few of the molecules of this cross section, this distance reduces, it becomes lesser than delta. Do you agree with me? So everywhere here, the distance becomes less than delta, whereas everywhere here, the distance becomes greater than delta. So we have contractive strengths on upper side of neutral axis and we have tensile strengths on lower side of neutral axis, and this, as these two molecules do not have change in distance, we call these molecules to lie on neutral axis or on neutral plane. Are you with me?
Sir.
Okay. Now so let us try to look at what is the effect of these pair of moments. The effect of this pair of moments is relative rotation. Why relative? Because there is a change in distance between two randomly chosen molecules on these two cross sections. So it is relative rotation, not a rigid body rotation. Agreed? Do you agree with me? Okay, Ayush, can you unmute? B division roll number 22. Ayush, no response in chat box, no response on microphone. I'm going to put the student in lobby. So Ayush, are you there? No, I don't think he is there. So I'm moving him to lobby. Now, Akhil Verma, roll number 21.
Yes, sir.
Are you with me till this point?
Yes, sir.
Okay. So therefore, this is relative rotation. Now look at the plane in which this relative rotation is occurring. This relative rotation occurs in this plane of board, and these two moments, they also lie in the plane of board. So therefore, this relative rotation occurs in the plane of bending moment. Do you agree with me? Akhil?
Yes, sir. Yes, sir.
In the plane of bending moment. So let us try to write down the effect of this rotation. So bending moment का effect क्या है? You are going to have relative rotation in the plane of bending moment जिस plane में है उस plane में ये relative rotation होगा. Now let us try to understand what is the effect of twisting moment. So I am going to redraw this skeletal member. Let me draw it here. So imagine that one of the end of this shaft is fixed, and you have moment M of this nature here, and you have moment M of opposite nature here. So under the action of this pair of moments, they are equal in magnitude but opposite in size. What happens to the bar? These moments have their axis along the axis of a skeletal member. So this pair we are going to call it by definition as twisting moment. So twisting moment also is the pair of bending moment, is the pair of moments. जैसे bending moment था, लेकिन the moments have their axis same as the axis of skeletal members. So ये difference है. Bending moment में moment का axis skeletal member के axis को perpendicular था, लेकिन यहाँ पे ये जो pair में दोनों moment दिख रहे हैं, उनका axis is along the axis of skeletal member. Therefore, we call it as twisting. Now, if I consider two consecutive cross sections which can be shown in this fashion, let us say this blue one, black one. This is one cross section, and let me take another cross section next to it, which is shown in blue line. These two consecutive cross sections. So in front view, I will be seeing this cross section. Let us say I am looking from this side. So I am going to have a look at the first cross section, and just behind this there is going to be another cross section, but just for sake of visualization I will draw that cross section with slightly larger diameter. Are you able to imagine this? These two cross sections are one behind the other. Are you able to imagine this?
Yes, sir.
Okay. So now under the action of this pair of movements, what is going to happen? This cross section which is marked in blue line is going to move in this direction, is going to rotate in this direction. And the cross section which is shown on black line, it is going to rotate in this direction. Consequently, these two cross sections, if I consider these two molecules, This molecule after the rotation will move here, and this molecule shown in black will move here. So there is sliding of two cross sections over one another. There is a relative rotation, but that rotation occurs in the plane of cross section. Do you agree with me? Do you agree with me?
Yes, sir.
So what is the consequence? Relative rotation, but in the plane of cross section or in the plane of twisting moment. क्रॉस सेक्शन और ट्विस्टिंग दोनों का प्लेन एक ही है इस केस में. द मोमेंट इज इन द प्लेन ऑफ क्रॉस सेक्शन, सो ट्विस्टिंग. So let me write down that here. So we are now about to close this cause and effect pair discussion. So this is also, twisting moment is also a pair of moments, but its effect is relative translation. Sorry, relative rotation. Oh, I wrote it as translation. I have to write it as rotation. Rotation ही लिखा है. So it is relative rotation in the plane of twisting moment or in the plane of cross section. So in general, what is the effect of force? Force can cause rigid body translation or relative translation. Then we define something called as axial force and shear force. We know that these forces are pairs of forces and they cause relative translations. Axial force will cause relative translation along the axis. Shear force will cause relative translation perpendicular to the axis in the direction of shear force. Uh, what is the effect of moment? So overall there can be a rigid body rotation or there can be relative rotation. When it comes to bending moment and twisting moment, these are pairs of moments. These are not isolated moments, pairs of moments. One across the cross section, one along the cross section. The one which is along the cross section we call it as twisting moment. Its effective is relative rotation in the plane of cross section. The one perpendicular to the cross section, we call it as bending moment. Its effect is relative rotation in the plane of bending. So we have now got acquainted with the definitions of basic four actions for which we do the design and their effects. ये सब तो हमें समझ में आया. Now we started with the question, what is design? Then we came to the actions for which we need to do design. We also discussed in length what are the effects of these actions, what is the cause and effect pair, action and effect pair. And now we are going to discuss what is analysis. So this is going to be the last point of today's class. So I'm going to ask few of you, what do we mean by analysis? So let us start with Ameya Gujar. Ameya, can you unmute and can you let me know what do you understand by analysis? Ameya.
Yes, sir.
Yes.
So, in analysis, we do check how the beam behaves under the load. Let us say we find the deflections of any of the structures. We find the forces that we get. Ideally, we check how much does the beam or any other slab, anything, it sinks, which is a relative translation, and how it bends, which is the relative movement.
Okay, good. Now let us go with Devansh. Devansh, can you tell me, Devansh Kedkar? Unmute and let me know. Can you add something to the definition of analysis?
No, sir. Analysis, as you said, sir, it is behavior of the given structure, the deflections it has given.
Okay.
Also, change in relative translation it has shown. That is analysis.
Sir, analysis meanings checking out all the parameters for finding the most optimum arm for the next step, which is decision making.
Checking parameters. Who said that?
Saifuddin.
Okay. optimization, and decision making. Okay. Now, let me ask Rishikesh Pandit. Rishikesh, A division, roll number 29. Can you unmute? You have to either respond in chat box or you have to respond over microphone, or I will consider you as absent. Rishikesh, are you there? No. So I'm moving you to lobby. Okay. Punit, can you unmute? Okay. Nikhil, C division, roll number 2. Nikhil,
Yes, sir.
can you unmute? Yes. Can you add something to this definition of analysis?
Sir, analysis means to examination. Means examination of forces, examination of behavior of a member and all.
Okay. Well, good enough. Now let me ask Siddhant Banerjee. Siddhant, can you unmute?
Yes, sir.
Yes. Anything to add to the definition of analysis?
Sir, most of the things have been covered, but if I were to add something more to it, analysis can also be described as a simulation before actually using the components for the building. So, like the way we, like, for example, we create artificial conditions in such a way that we are able to check the viability of the structure for the future.
Yes. Very good. Chalo. Dhruv, can you add something to this? A division, roll number 35. Yes.
No, sir. I think all the points are covered.
All the points are correct. Okay. Mahadev Nair, can you add something? Mahadev? No response. I am going to assume student is absent. Okay. Ankit Raj Rana, B division 19, roll number.
Yes, sir.
Yes. Can you add something?
No, sir. I think
It's covered.
everyone.
Okay. So now I request any one of you who has another point to unmute and let me know if you want to add something to this. I will wait for maybe 30 seconds.
Yes, sir.
Yes, go ahead.
So we can say the detailed examination of the structure which is a complex one.
Detailed examination. So somebody said examination, so I will just add a word detailed here.
Yes, sir.
Anything else? Okay. So instead of giving you the definition of analysis, which also is a evolving definition, as we said for design, but instead of doing that, what I will try to do now is maybe not in this class, but in the next class, what we are going to do is we are going to list down the various units that you have learned in strength of materials, and we are going to associate these words which are tossed by your classmates with each of these units. तो हम क्या करने वाले हैं, एक एक यूनिट में यहाँ पे स्ट्रेंथ ऑफ मटेरियल्स का लिखूंगा और हम इन वर्ड में से कौन सा वर्ड किसके लिए अप्रोप्रिएट है. It's like match the pairs, and the match may not be unique. You may have 2 or 3 descriptions for the same chapter, but I hope you have understood the idea what I'm trying to say. Have you? Any one of you can unmute and let me know. Have you
Yes,
understood?
sir, understood.
Yes. So let us try to list down this strength of material chapters, and then we are going to stop for today. You are going to do a homework. You will associate these words with these chapters. Yes, mapping is not unique. There may be multiple descriptions for a single unit, but I will try to list down these units. So the very first thing that you study in strength of materials is possibly the definition of stress, strength. Then in that same unit you must have learned about temperature stresses. तो ये सारी चीजें आपने पहले चैप्टर में सीखी है. Are you with me?
Yes, sir.
Yes, sir.
Then in the second chapter possibly you would have learned first level diagrams, like axial force diagram, axial force diagram, then shear force diagram, SFD, then bending moment diagram. Units may be different, but these diagrams can come under the single category as far as analysis is concerned. So axial force diagram, shear force diagram, bending moment diagram, and twisting moment diagram. These are the first level diagrams that you must have learned. Then you must have learned bending and shear stresses. Bending and shear stresses. So bending and shear stresses, they basically come from two formulae. One is bending formula, which we write it as sigma by y is equal to m by I in crude form is equal to E by R. This is one formula that you must have dealt with, and another formula is similar to this. It is tau by R must be equal to T by J, or polar moment of inertia, and is equal to G theta by L. So these are the two formulae. Units may be different, but we club them together as one class, and that is bending and shear stresses. Are you with me? Do you remember any of this? At least slide of it?
Yes, sir. Yes,
Yes.
sir.
And then you must have learned a chapter on columns where you talked about buckling and all those phenomena. Columns. And the king chapter of strength of materials. That is principal stresses and principal planes. Are you with me? याद आ रहा है ये?
Yes, sir. Yes.
Principal stresses and principal strains. So what I want to do is, as per this classification of the chapters that you have learned in strength of materials, you have learned it as a piece of a mechanism, but now we need to stitch it together to look at the global picture. So for that, the first step will be, whatever word that your classmates have taught here, try to associate these words with these chapters. That is your homework. And then in tomorrow's class, we will define what is analysis. It is an evolving definition. So we will come up with the contemporary understanding of analysis. And then we will proceed in this course. Okay. So let us stop here. On your group, last time I forgot to share the attendance link. Now I will do it. I will share it. Okay.
Okay, sir.
If anyone has any doubt, please let me know, or else you can leave the class. No need to put the attendance here. I'm sharing the link.
Thank you, sir.
Thank you so much, sir.
Thank you, sir.
Have a good day.
Thank you, sir.
Thank you, sir.